Hello there, this is Randy. Today we're going to talk about what are the zeros of a polynomial, where do we find those zeros on the graph, and how do we identify the zeros of some polynomial in factored form. Let's go. So this question says, what are the zeros of the following polynomial? And this polynomial is called p of x. Before we try to answer a question like this, let's talk about graphically, what are the zeros of a polynomial? Well, here we have a graph of some simpler polynomial, y equals x squared minus 6x plus 5. Let's call this polynomial f of x so that it looks like other problems that we'll deal with. So before we try to identify what are the zeros of this polynomial algebraically, let's talk about graphically what are the zeros. Well, the zeros are the x values when y is equal to 0. Okay, so where is y equal to 0 on the y-axis? Well, obviously right there, y equals 0. So this blue line right here is y equals 0. Interestingly, the line y equals 0, this horizontal blue line, is also the x-axis. Now, once again, the zeros of our polynomial are the points on the graph where the line y equals 0 touches the curve. So another way to think of the zeros is x-intercepts, because this point right here and this point right here are the two x-intercepts of our graph because they touch the x-axis. So now exactly what are these points? Well, it looks like this first point is 1 unit to the right of the origin, right? So that is x equals 1. And this next point is 5 units to the right of the origin, so that will be x equals 5. So it's pretty obvious that when we have a graph like this, finding the zeros, or the x-intercepts, is not that complicated. But let's imagine that we did not have this graph. How would we find the zeros of our polynomial? Well, perhaps the easiest way is to factor if possible. So this expression right here could be factored into two binomials. So first binomial and second binomial. We have x. We've talked about this in previous videos, so feel free to go back and look at our videos on factoring polynomials if this looks a little bit strange to you. So now this number and this number that we don't know yet, multiplied need to be 5 and added need to be -6. Those two numbers in this case are -5 and -1. -5 and -1. Okay, now back to finding zeros. The question is, what values for x will make this expression 0? That's the question. Well, we know that these two binomials are being multiplied. So think about it like this. If this entire binomial right here is 0, the entire expression will be 0 because anything times 0 is 0. In the same way, if this entire binomial is 0, then the entire expression, the entire polynomial, will be 0. So really the question that we're asking is, what value of x will make this 0 or will make this 0? The easiest way to find out what values of x will make each of those expressions 0 is to set this expression equal to 0 and set this expression equal to 0. Remember, if this entire side of the equation is 0, that means that y is equal to 0, which is exactly what we're talking about graphically, when y is equal to 0, or when the graph touches the x-axis. So I just took this binomial and set it equal to 0 here, and took this binomial and set it equal to 0 here. So now let's solve for x in both cases. So x minus 5 equals 0. We're going to go plus 5 on both sides to get the x alone. That will give us x is equal to 5. And when we do plus 1 and plus 1, we're going to get x is equal to 1. Now look at that. X equals 5. Good to go. X equals 1. Good to go. So when we have a polynomial in factored form like this, finding the zeros is just about as easy as finding the zeros when we have a graph. All you need to do is set each factor equal to 0 and then solve for x. So let's do a couple more examples where we need to find the zeros of a factored polynomial. So just like we did in the expression above, we're going to set each of these binomials equal to 0. So now we have three very simple equations. Let's solve for 0 in this first equation right now. So 2x minus 5 equals 0. We need to go plus 5 and plus 5 on both sides. And that will give us, when we add 5 to both sides, just 2x on the left. And on the right, we get positive 5. Now we have not found x yet. Now we need to divide by 2 and divide by 2. So when we divide by 2 on the left, we just get x. So we're close. Now 5 divided by 2 is 5 over 2. Or you could say 2.5. That's easier to conceptualize when we're thinking of a graph. So that's like between 2 and 3 on the x-axis. Okay, perfect. So there is our first 0. The first 0 is 2.5. Next one is, let's find out. So we have x plus 1 equals 0. So we need to say minus 1 minus 1. We get x is equal to negative 1. And plus 7, we get x is equal to positive 7. So our three zeros in this case are x equals 7, x equals negative 1, and x equals 2.5. Now this last example might feel a little strange because here we have an x as one of the factors, but that is actually even easier than when we have a binomial. So let's set x equal to 0, 2x plus 1 equal to 0, and x minus 3 equal to 0, and then we'll find the values for x. So if we say x equals 0, what does this mean? So one of the zeros is 0. So now let's solve for x in both of those. So here we're going to go plus 1 on, I should say minus 1 on both sides because it's a positive 1 here. So minus 1, we get 2x on the left, and then 0 minus 1 is negative 1. Divide by 2, we get x is equal to negative 1/2, or you could say negative 0.5 is the value of x. So there's another 0, negative 0.5. And plus 3, we get x is equal to positive 3. So if you looked at the graph of this polynomial, you would see that it touches the x-axis at the origin, x equals 0, at x equals negative 0.5, or negative 1/2, and x equals 3. So as a review, whenever we need to find the zeros of a factored polynomial, all we need to do is set each factor equal to 0 and then solve for x. And with that, we are finished. See you next time.